What's going on, Algebros? In this video, we're going to knock out the last two parts of what I like to call the box problem. We will be utilizing the graphing calculator for most of this. So if you have yours near you, go ahead and get those ready, because we're going to put them to use before too long. So let's go ahead and dive right into it. It says using your graphing calculator, sketch a graph of the function from part A and indicate the window settings you're using. All right, so keep in mind our function from part A is v of x equals x times 14 minus 2x times quantity 10 minus 2x. That's what we're going to enter into the graphing calculator, and that's going to go in our row for y1. So y1 equals x, parentheses 14 minus 2x, parentheses 10 minus 2x. So I'm going to go ahead and get out my graphing calculator. And in the y equals menu, x, parentheses, 14, big minus sign, 2x, close off the parentheses, open up a set of parentheses again, 10, big minus sign, 2x. Now, if you hit zoom option 6, the standard viewing window, you get a little section of the graph, and unfortunately, this section of the graph isn't really going to be helpful for something like part D of this problem, where we have to find the value of x that maximizes the volume. Believe it or not, there is going to be a maximum value. We'll figure out what x value creates it. But unfortunately, using the standard viewing window, that's not going to help. So I'm going to go ahead and help you navigate through choosing the window settings so that we can see the section of the graph that's actually relevant to the problem, as well as determine what the maximum value is. So let me go back to the notes here. One key thing is the window settings, obviously, and I'm going to pick on the settings for x to start things out. Keep in mind that our domain for this problem is between the values of 0 and 5. So what that means is you might want to use set your x min value to 0. We don't want to use x values less than that. And you might want to set your x max value to 5. So along the x-axis, we're going to be going from 0 to 5. And we can leave the x scaling at 1. So let's see what that does. We'll go back to our graphing calculator. We'll press Window. We'll change that to 0. We'll bounce down to row 2, change that to 5, and we'll leave the x scale at 1. Let's go ahead and press Graph to see what this produces. Okay, so again, we're not really seeing a good enough picture of the graph, but you can tell a little bit that there is going to be a maximum. At first, we saw the graph shoot up rapidly, and then it came back down. So there is some sort of hill in quadrant 1, which is implied by what we're seeing. So we'll have to adjust our y values to see that hill. So let's go back to the notes. And we're going to go ahead and pick on the y min, y max, and y scale values. So one thing that we can assume here is that y min can be set to 0. And that's because any negative y values would correspond to negative volumes, which have no practical meaning. As for the y max value, I find that starting out with 500 in problems like these is a good baseline for any further adjustments that are needed. As for the y scale, I'm not going to leave that at 1 because that will make the y-axis very thick, and the OCD in me doesn't like a thick y-axis. So what I'm going to do is maybe go by 100ths on the y-axis so there aren't a ton of tick marks on it. So let's go back to our graphing calculator. Let's press Window. bounce down to the y stuff. Y min will be 0. Y max will be 500. And we're going by 100s on the y-axis. Let's press graph. All right, so 500 was probably more than what was necessary for the y max value, but I'm okay with leaving it at 500. If you wanted to lower it a little bit, that's up to you. But just make sure that whatever you change y max to, you're still able to see this hill in quadrant 1. So I'm going to leave the window settings as they are. Of course, y min was 0, but the y max was 500. And this is kind of what the graph did. And that's actually all you need to do for part C. Part D is an extension of part C, though. It says for what value of x is the area, for what value of x is the area of the volume largest? What is the largest volume? Round each answer to 2 decimal places if necessary. I think there's kind of a flaw in the first question. Basically, we're trying to figure out where the maximum value on this graph is. So we want to know what the x value is, and we also want to know what the maximum is. All right, so because this is a hill in quadrant 1, there is going to be some sort of maximum, maybe about right here. And that would be considered what's called an absolute maximum. And the graphing calculator can help us to determine where this is at, or at least help us approximate it. So that's what I'd like to do next. I'm going to go to the graphing calculator, and we're going to press second trace, and we're going to choose option 4, maximum. And we need a left bound and a right bound. I'm going to go back to the graph real quick that I sketched out. A left bound is going to be somewhere right here on this graph because that's to the left of where the maximum is. So when the time comes, we'll put our blinking cursor here and press enter. And then it's going to ask for a right bound, which a good right bound will be maybe about right here on the graph because that's to the right of where the maximum is. So when the time comes, we'll move our blinking cursor over to that part of the graph and press enter. And then it's going to ask you for a guess, in which case we'll get our blinking cursor as close to the maximum as possible. So I'm being asked for a left bound, so I'm going to scooch over to the left using the left arrow key. So I'm a little bit to the left of that high point, maybe about right there. And then as I mentioned, it's going to ask you for a right bound, so we're going to go to the other side of this maximum. Press enter. And then we want to guess. So what I'll do is place the blinking cursor somewhere between where my left bound and right bound entries were at. I'll go ahead and press enter. And it places the blinking cursor on the location of the maximum. Rounding to 2 decimal places, we're looking at 1.92 as the x value. And then 120.16 as the y value. So to answer the first question, the square needs to be approximately a 1.92 inch by 1.92 inch square. That'd definitely be something that something difficult to just guess off the top of your head. And then the maximum volume is given by this y value right here. And that's going to be 120.16 inches cubed. And that's how we solve a box problem. All right, hopefully this helped clarify any misunderstandings you may have had about it. Of course, if you have any questions, feel free to let me know. Otherwise, thanks for watching, and I'll see you guys next time. Goodbye.